Hey guys, hope everything is going well. So we're going to do this distance learning thing, but it's not a big deal for us, right? You've been doing this all year. Watch a video, you do a reflection, you do some practice, and then you do some more practice. So same old for us. The only difference is I can't see you, and that does make me sad. I miss you guys. But I'll be on Google Hangout, so I'm going to try that. And if not, you guys can email me. A couple kids have done that all year. I'll email you back. If I can't answer it, I will write out a solution and send you a picture. I can make you a real quick video and send it. Not a big deal. So we got this. All right, so sorry I was out the Friday before break, but my daughter was sick with just a cold. Not a big deal. So I left you guys an ed puzzle to learn mean absolute deviation, and I am just sad that only 2 people did it, but I did read the subnotes, and I know they picked up iPads, and a lot of you don't have your technology ready at school, so let's do this again. So instead of the ed puzzle video, which I'm not sure if you can still get to, I'll go back in and see if I can make that take longer in case you want to go through that. I'm going to make you notes. Okay, so you need to have like paper to write on, so your journal or something to write on. So pause the video, go get something to write. You're going to need to take down notes. Now, the good thing is you have this video, so if you're like, yeah, whatever, I'm not going to do that, then, you can always just refer back to the video. The other thing you could do if you don't have paper or pencil or whatever, I'm just not sure how this is going to work, you could do digital notes. So you could go back and make yourself a PowerPoint or a spreadsheet like this. I could share this one with you that I'm putting in Explain Everything. It just won't have all my writing on it. So I'll do that in case you guys want that as well. Okay, so mean absolute deviation, or we abbreviate it by MAD, and I forgot my period there. There we go. All right, so mean absolute deviation basically focuses on the fact that we are going to find the mean. And I think we talked, but I don't know, I get confused between you guys in the 7th grade, that the mean means the average. And you learned that, back, I actually think you may talk about it in 5th grade. I know 6th grade does it, and I know you guys did like mean, median, mode last year. The only thing that 8th grade talks about really is the mean, to do this mean absolute deviation. Okay, so that's the average. So we need to find the average. So remember, to find the average, that's where you add everything, add all the numbers, and then divide by however many you have, Okay, and of course, use a calculator, not a big deal. All right, now the rest of this, absolute deviation. Okay, so what deviation means is it's like a variable. How much does it vary from the norm? Okay, an absolute deviation, we're talking about those positive distances. So this part of it means how much is it different from, how much does it differ from the mean, each piece of data. Okay, so I was just online looking, like, why would you need to use this? So there's a lot of information out there. This is like used, if you take statistics in high school or college, you're going to see this mean absolute deviation used. And what I found is they use it when they do forecasting. So whether it's weather forecasting or I don't know, I'm working for some research lab and I want to predict what's going to happen with my experiment. Evidently, they take all of the differences, the errors that can occur, because when things are varying, you have something called error in statistics, and they use mean absolute deviation to kind of define that. So what it's going to do is tell me how much my data varies from the mean. Okay, so it's kind of like range. When you did range, you found the range of a set of data. And so if you had a really big range, like if I look at your test scores and I have a huge range, then I'm like, okay, some people don't have any idea what's going on, and some people know exactly what's going on, and everybody's all over the place. So if I have a big range, I'm not going to use the mean to describe that data, because it's not going to be right. I have some outliers in there somehow that's making this range really big. So this is kind of the same thing. If your mean absolute deviation is really large, that means the numbers are kind of far away from the mean. they're not all kind of clustered around the mean, so they have a great deal of variability. They're spread out. And that could mean I just have like 1 or 2 outliers. It could mean I have them all. What it would mean for me if I look at that is, maybe the mean isn't the best measure to describe my data. If I'm looking at test scores and I have a huge mean absolute deviation or range, then I'm going to look probably at the mode. I want to know what most people did. And then that's why we have the reteach, right? We kind of clean up, like there's always a couple people here and there that, in every class, I always have a couple tests where I have like 2 or 3 people that just got confused. So, then we do the reteach. Okay, so mean absolute deviation is based on the mean. So, let me tell you, it has 3 words, right? There are 3 steps to find this, and all it is calculation. All you need to be able to do is add and divide. You just have to remember to do it twice, and subtract is in there too. All right, so let's go on to the next slide. Okay, so I found this from good old Khan Academy, okay, because I decided maybe you didn't want to have to try to read my handwriting. All right, so mean absolute deviation of a data set is the average distance between each data point and the mean. So it gives us an idea of the variability in a data set, or how spread out it is. How spread out it is. Spread out the data is. So when I was looking up examples and such online, I found a lot of lessons kind of refer you back to a dot plot. You remember the comparison a lot. All right, so here's how we calculate it. Like I said, it's just a calculation. You're going to find the mean, so calculate the mean, which means you're going to add all of your numbers up, divide by however many they are. Okay, and remember another word for that is average. Okay, now you're going to calculate step 2, calculate how far away each data point is from the mean using positive distances. That's where the absolute deviation comes in. Absolute differences, you could even say. How am I going to find the difference? I'm going to subtract. So I'm going to go and subtract the mean from each of my data points. Okay, and I just want it to be positive. So if I subtract and I get a negative number, that just meant that particular data point is below the mean. Right now, we don't care about that. Later on, if you take a statistics course, it does matter. You could have a negative mean absolute deviation, but right now, we're just all being positive. We're just looking at the distance from 0, so it's going to be positive. Okay, and then step 3 and 4, they break it down. Add the deviations together. You're going to add those differences together and divide. So what are you going to do? You're going to find the mean again. Okay, so you're going to find the mean, you're going to subtract, you're going to find the mean, and that's it. Okay? You had like here, and then it was like, it looked like this for whatever this is. Maybe this is ages of people somewhere, and you have like 10, 12, 14, then maybe you had a whole bunch of people here, and maybe 1 here. I don't know. Okay, so those dot plots, they show you how your data is grouped. That's one of the advantages of using a dot plot. So mean absolute deviation is going to show you how much variability it is. So they made that. Okay, so let's look at an example. Okay, remember 3 steps. Find the mean, subtract, find the mean. Okay, so Erica enjoys posting pictures of her cat online, and this is how many likes the past 6 pictures each received. Okay, so I know that I have 6 data points, okay? And I have to find the mean absolute deviation. So my first step is to find the mean of my original numbers, okay? So to do that, I need to add these together. So I'm going to do 10 plus 15 plus 15. Okay, so you should be writing this down. I always forget to tell you to write stuff down. I just assume you will. But if you've written nothing down yet, write this example down so you can see what to do. Okay? And then because I have 6 data pieces, I'm going to divide that by 6. Now, if you had the Inspire calculator, and I will put a link on the classroom. I read somewhere that TI was giving a trial for to use the online one for, because of all of this, for quite a few, like a month or two or something. So I'll look for that link for you. If you're using an Inspire, you need parentheses, or any other kind of graphing calculator you might have at home or whatever. If you are using the calculator on your phone, I believe you can still do this. You need parentheses. If you don't, it's going to follow order of operations, and it's only going to divide the 21 by 6. You're going to get a really weird number, okay? Or you just add them all up, hit enter, then hit whatever, divide by 6, and hit enter, okay? All right, so speaking of that, let me go find my calculator. Okay, my daughter stole it for the TV remote. Okay, 10 plus 15 plus 15 plus 17 plus 18 plus 21 is 96. And 96 divided by 6 is 16. So this is 16. That's my mean. Okay, so that's step 1. Step 2 is I have to find these absolute deviations. So I have to find the distance. Each of these numbers, 10, 15, 15, 17, etc., is from 16. So my second step is I'm going to subtract the mean, which in my case here is 16, from each data point. All right, so I'm going to kind of write all of this down this way. I'm going to link a video too that will show you. It puts it in a little chart, and that might organize it better for you. All right, so I'm going to do 10 minus 16 or 16 minus 10. Doesn't really matter because remember, we want it to be positive anyway. So that's 6. Then I have 16 minus 15, and that's 1. And then 16 minus 15 again, and that's 1. And then 16 minus 17, which I know is -1, but I'm going to call it 1 because I want the absolute value. I want the positive distance. Well, I want the distance, which is positive. Okay, 16 minus 18. Again, I know that's -2, but I'm going to call it +2. And then 16 minus 21, which is 5. Okay, and then my third step then is to find the mean again. So you're going to find the mean twice. Okay, so now I'm going to find the mean of my differences. So the mean of the differences, or the deviations, if you want to talk fancy statistics talk. Okay, so that's 6 plus 1 plus 1 plus 1 plus 2 plus 5. And again, there should be 6. Okay, and let's see, 6, 7, 8, 9, 10, 11, 16. Divided by 6, which is 2.6 repeating. So 2.6, that's going to repeat. So what I would say is, oh, I put a 2 there. Oh, now I can't erase it. Oh, yeah, I can. Sorry, that's step 3. All right, so the mean absolute deviation, I'm going to call this 2.7. You're just going to round it because this is 2.6666666, right? So it goes up 1. Okay, and usually they are 1 or sometimes 2 decimal places. They wouldn't use a bar notation. I've not seen that. So you might see like an answer choice be 2.67. Okay? All right, let's look at, I think we have another example. And we do. This is a list of data that I got from the Edpuzzle video, that last one that I asked you guys to watch. And what Edpuzzle will do is it tells me the percentage of the video that you watched, and it also, just so you know, tells me how much time you spent on it, which is good information. So I just took a couple. There was a whole bunch of zeros, but, like I said, they took the iPads back, day before spring break. Yeah. So I just took 8 people randomly, and I will tell you there were a few other hundreds, like maybe 2, and then the rest, not so much. All right, so I have 8 students, and the good thing about this mean absolute deviation, and all the problems that I looked at, it always tells you how many numbers we're going to give you. So you don't even have to worry about miscounting the numbers. Okay, so find the mean absolute deviation. The first thing I'm going to do is find the mean. Okay, now, if I were you, I would pause the video. I would go ahead and do that, and then I would play it to see if I did it right. Okay, all right, so I'm going to add all these together. 20 plus 100 plus 30 plus 70 plus 0 plus 10 plus 100 plus 70, and then I'm going to divide them all by 8. And remember, if you're putting that in a calculator as all one problem, you need parentheses around here so the calculator adds everything and divides the sum by 8. Otherwise, it will only divide the 70 by 8, and you're going to get a weird number. Okay, so I'm going to grab my calculator and let me do this. 20 plus 100 plus 30 plus 70 plus 0 plus 10 plus 100 plus 70. 1, 2, 3, 4, 5, 6, 7, 8. Make sure I got them all. That gives me 400, and then divide by 8, and that gives me 50. Okay, so one thing I'm realizing as I'm doing this, these means are coming out even. A lot of times they won't. Like if you get 50.3, just round it to the whole number. Okay, so for this first step, to make it a little bit easier on us, we're going to round to a whole number here. That's the only time we're going to round to a whole number. We can have a decimal for the mean absolute deviation. You don't have to round it to a whole number because you have calculators and you push decimal points on your calculators, not a big deal. But if you want to, that'll make it a little bit easier numbers to work with, and it doesn't make it that much of a difference in the end. You will still get the correct answer. All right, then the second step is we are going to subtract to find the differences. So we're going to subtract each number in our original set from 50, or 50 from each number. Again, doesn't matter what order you do it in because we're just taking the positive number anyway. So 50 minus 20 is 30. 50 minus 100 is, I know, negative 50, but we're going to do 50. And the distance between 50 and 30 is 20. The distance between 50 and 70 is 20. The distance between 50 and 0 is 50. The distance between, where am I at, 10, 50 and 10 is 40. The distance between 50 and 100 is 50. These are all subtraction problems. And the distance between 50 and 70 is, again, 20 units. Okay, so that's step 2, so a little bit of subtraction. And then step 3, find the mean again. So I'm going to find the mean of the differences, which is the mean of these numbers here. So that means I'm going to add these numbers up. So 30 plus 50 plus 20 plus 20 plus 50 plus 40 plus 50 plus 20. 1, 2, 3, 4, 5, 6, 7, 8. Divide by 8. I just count to make sure I didn't miss any. Okay, and I'm just going to grab my calculator, and I'm going to do that. I'm going to do it all as at once, so I put parentheses. 30 plus 50 plus 20 plus 20 plus 50 plus 40 plus 50 plus 20. 1, 2, 3, 4, 5, 6, 7, 8. Make sure I didn't miss any. In my parentheses, then I'm typing a division, and I'm just using my phone. Divide by 8, and I get 35. So, oops, need a pen. My mean absolute deviation is 35. That's a pretty big mean absolute deviation. So that tells me my data varies quite a bit. So if I knew nothing else but my mean absolute deviation was 35, I would know I have people finishing all over the place, you know. Now, what I don't know is, you know, do I have one person that finished and, you know, most people didn't? Well, I know that because I looked at the data. You know, it doesn't tell you that specifically. It just tells you how much your data varies, and then you can make decisions based on that. So as a teacher, if I look at like test scores and I see a lot of variability, then I have to make decisions based on that. I know the mean isn't an accurate description of my data, because I could just have one or two people. I could have one person that doesn't understand at all, one person who gets everything, and everybody else is somewhere in the middle. You know, that just tells me I need to look closer. If my mean absolute deviation is very small, and my mean is, say, 84, like on that last test we took on volume, I think that was the test, volume, Pythagorean theorem, the last couple of tests you guys took, like, the class average was an 84 or something like that. So if my mean absolute deviation is very small and I get a class average of 84, then I'm pretty happy, because most people then are right in that area. It's not going to vary a lot. Okay, now I might have a couple people, you know, maybe got 60s and they want to do their test over. That's not a big deal. Okay, so mean absolute deviation, you find the mean twice, and what it tells you is how far apart your data values are from the mean, which tells you how spread out your data is. Okay, that will determine whether or not the mean is going to be a good predictor. Okay, now the only thing that the 8th grade TEKS say is you need to know how to find this. They don't really address like what do you use it for, but hello, we want to know what we use it for, right? So that's what you're going to use that for. Just like last year you used the range to decide what measure of tendency was best to use, the mean, or maybe you needed to use the median or the mode. In 8th grade, the mean absolute deviation tells you how spread out your data is. It's just instead of, you know, the distance between all of the data points, is the distance between the mean and all of your data points. Okay? All right, so your next activity then is going to be to do the Google form, and that's one of those branching forms that if you get the question wrong, it's going to take you to a video, and then an extra practice question, and then you have some other activities. And I forgot to tell you in the beginning, so you've noticed, I'm sure, I've put on, and I know I emailed you all and your parents, and I will put this on the classroom as well. I put everything on for the week. I don't know what your schedule's like. I don't know what responsibilities you have at home. I don't know if you can be on the computer every day. How many siblings do you have, etc. So I kind of broke it up. If you want to work every day, it should be about 20-30 minutes every day. That's fine. If you're like, no, I have Tuesdays, I know I can get stuff done, then get as much done as you want on Tuesday. Okay, so I gave you the entire week till Monday, kind of a time frame. But trust me, ask me how I know this. Do not wait for the last minute because you don't feel like doing it. Okay, it'll be much easier if you make yourself, if you have the time every day, sit down 15-20 minutes and do math, 15-20 minutes do whatever else, or you could break it up. I'm going to do math Monday, Wednesday, Friday, and ELA Monday, Wednesday, Friday, and science and social studies Tuesday, Thursday. Okay, so that is kind of the cool thing about this, is you can do it when you have time. You can do it whenever it is you have time. If you sleep late and get up, stay up late, it doesn't matter. Just know that I will not answer any of your emails after 9 o'clock. And if you've emailed me, you know that, okay? And I will try not to post anything or put anything on that's going to make your phone go off before 8 a.m., okay? All right. So go ahead, good luck. Let me know if you have any questions. Respond in classroom or go to the Hangouts. You can get in touch with me. Okay, good luck.